For those that are not familiar with test-driven development, or TDD, test-driven development is an alternative software development technique that uses a test-first approach in its design philosophy. It's called test-first due to how unit tests are written before any production code is developed. Looking back at TDD, we can see that traces of its practices can be seen spanning back to the mainframe and punch card days of the 1960s. It's also been known throughout computing history by different names, most notably test-first programming, test-first design, and test-driven design. In more recent years, TDD has been popularized by the extreme programming movement of the 1990s. Since that time, it's earned even more notoriety within the Agile framework after the release of the Agile Manifesto in 2001. Besides its affiliation with extreme programming and Agile, TDD has also been used as a standalone practice within software development. When looking at how TDD works, the TDD development lifecycle consists of the following steps. In step 1, we add a test. This is typically to address a particular software requirement. We then run this test to see if the new test case passes or fails. Since there's no actual code to support the test inevitably fails. From here, this is where we proceed to write the actual code to fulfill a particular software requirement. This bare bones code is often less structured and ideally just enough code to satisfy the test conditions. From this state, we can now run all the tests again to see if the new and old test pass. If the test fails, we need to continue adding production code to the previous step until it does pass. If the test passes, we can then look at re-examining and improving the code's design through a process called refactoring. This refactoring improves the code structure by reducing the complexity and improving clarity of the design. Since this is an iterative process, once this is done, the developer can look at adding additional test cases and move towards adding additional functionality. It should be noted, though, that despite the emphasis on testing from its name, TDD should not be viewed as a testing technique. This is because while testing is a core component of TDD in its life cycle, the primary purpose of TDD is to serve as a programming and design technique in the software development process. This approach of testing first before writing any production code may sound foreign to some, but in doing so, it can give developers added benefits, especially when compared to more traditional test-last approaches such as the waterfall or spiral methods. Proponents of TDD believe the design process produces higher quality code that is simpler and less coupled. This is mainly due to the simplified design of the code during implementation and due to the constant phase of refactoring where the programmers are able to improve the quality of the code structure and eliminate duplicate code. Code produced by TDD can also be viewed as more efficient since developers can break code into smaller units that can be written and tested independently. This can produce a more integrated and efficient product. Given that testing is implemented throughout the entire process, time spent debugging at later stages is also minimized. Furthermore, as these tests provide instant feedback, developers are better able to decompose the problem into more manageable tasks that ultimately lead to greater integration between components with fewer defects. One aspect of TDD that has been commonly criticized in the past is the lack of upfront design its development lifecycle employs. Typical plan-driven approaches see more detailed planning done up front, but due to TDD's emphasis on smaller upfront design with frequent refactoring, TDD efforts can occasionally lead to lack of design correctness, which may lead to major restructuring events at later stages of the project. Another disadvantage that may affect overall product quality is the completed TDD projects are only as good as the tests that have been used, the thoroughness for which they've been done, and the extent to which they mimic conditions encountered by users of the final product. Skeptics also argue that TDD is hard to learn and is counterproductive. Even when developers agree to use TDD in future projects and acknowledge that it's to be an overall better solution, they also perceive it to be more difficult when compared to more traditional development methods for which they're more comfortable with. Lastly, some consider increased development time as a distinct disadvantage of using TDD. Studies have found that many organizations do experience an overall increase in the time spent in the development stage. However, some may argue that this is an acceptable trade-off to the long-term benefits associated with increased product quality and lowered defects. In the long run of a project, the overall development time may actually not be as long if you consider the decreased time debugging and dealing with the defects later in the project. So that's another factor to consider. Now, let's look at implementing a simple software solution using TDD. In step one, we look at implementing an actual test case. Depending on the development platform, there may actually be some libraries that help you automate this process. In Java, the JUnit imports are a popular solution for this. In this example, what we're doing is creating a simple test case for a dummy function called crazy function and its calculate method. If we pass the word apple into this method, the test will fail if the output does not equal apple slices. Now, if we run this code, the compiler will fail as there is no actual code to calculate the crazy function. Once we know this will fail, we now need to code the actual function and methods for crazy function. In this code, all we're doing is passing in a variable into the calculate method. If the variable equals apples, then apple slices return from the function. If not, the method returns mush. If we compile this code, the test case should now pass. The test passes. This means we can proceed to refactoring, if applicable, or proceeding to implementing another test case in response to another software requirement. Again, this Apple scenario is a very simple example of TDD in action. Where the power of TDD comes in is when you can continuously build on these test cases. If you continuously keep adding these test cases and all your previous test cases pass, we know that there's no integration issues with any of the previous code in your new code. If you happen to add in a new test case, such as our test boulder test, and the test apples test case starts failing, we know any new code added to pass the test boulder test may not have integrated well with our current code base. During many large-scale software projects, it's oftentimes difficult to see how these different software components integrate with each other. We would then need to go back and reevaluate the test boulder code or look at better integration of our earlier code with the newly added code. In conclusion, if you're interested in creating more simple, efficient, and more integrated software solutions with less defects, test-driven development is definitely an option to help you achieve this. Although increased development time may be perceived initially, if done right, the long-term benefits of increased product quality and less late-stage debugging may actually be an acceptable trade-off. For additional information on TDD, please refer to your preferred software development platform for documentation on the availability of TDD tools, or seek additional resources online from the software development community for keywords such as Agile, Extreme Programming, JUnit, TDD, and Test First Design.